This is the Building Automation Monthly Podcast with Phil Zito, episode 123. Hey folks, Phil Zito here, and welcome to episode 123 of the Building Automation Monthly Podcast. And in this episode, we're going to be talking about the pros and cons of IP controls. I was on the phone with a customer of ours yesterday, I believe, at the time of this recording at least. And we were talking through just kind of what they're thinking about doing when it comes to retrofitting their building and how they have an existing proprietary network in their building, so they can't utilize that. And that's a whole nother topic about utilization of existing trunk runs and things like that and the pros and cons of that. But we started getting into IP controls. And specifically, just how would they be implemented? How would they work with the customer's IT group? What are the pros and cons of IP controls? And I realized after having that conversation with him, that's not a topic we've covered. And outside of all the marketing stuff, depending on whose product you're looking at, there's not really any agnostic pros and cons about IP controls. The reality is IP controls aren't new. I mean, we've been using them for a long time, just in supervisory control, IP controls to chillers. Lawn is really well known for having EIA 852 IP controls. So we've had IP controls. It's just that they haven't been widespread because the cost point was normally very prohibitive. And just from a perspective of wanting to separate ourselves from IT, we haven't pursued those. We just, as an industry, haven't went after that market. Now, the reality is nowadays IP controls are pretty cheap, relatively speaking. Cost of Cat 5e, Cat 6 is relatively inexpensive. And with some of the topologies, which is a fancy way of saying physical layouts, that we're going to talk through in this episode, you'll see that it can actually not be as expensive as it used to be from a installation and a supporting perspective. So IP controls are essentially the same thing we've been doing with supervisory devices. All that's happened is that we have went and essentially taken the protocols that were used at the supervisory layer and we've pushed them down to the field layer. You have to remember, back when controls started, back when we made that shift from electromechanical controls to DDC, and then when we went from DDC and we started to branch out to using things like RS-45 with BACnet MSTP, N2, Siemens S-Bus, or P-Bus rather, things like that, we started to go and have these field serial networks that were basically daisy chain networks. And then all of those went to a protocol gateway. That's what the original supervisory devices were. They were these protocol gateways. Essentially, they were taking serial bus networks and converting them to a higher level, usually at the time ArcNet or Ethernet speak, that was allowed to be transferred on a local subnet. Now, what happened is, so you've got this supervisory device, and it's acting as a gateway between this serial network, RS-45, RS-232, so BACnet MSTP, Modbus RTU, those kind of things. And it's translating it to BACnet IP, Modbus TCP, etc. Well, with these IP controls, now we're eliminating that layer. And that's why, just on a side note, one of the big things I think you'll see over the next couple years will be the disappearance of supervisory devices, or at least the migration of supervisory device capabilities to lower tier controllers. So you'll see more of the processing of alarms, of extensions, of user interfaces, all of that kind of going to a decentralized model where it's less in a supervisory device, less in a server, and going to field controllers. And eventually we will see the supervisory device layer disappear, and you'll just have servers and field controllers. And most likely those servers will be in the cloud, which is another topic for another day. With all of that being said, though, this is kind of our first step here, these IP controls. And the primary protocol we're going to be concerned with when we're dealing with IP controls is BACnet IP. Just whether you like it or not, whether you're a diehard other protocol fan, BACnet IP has captured the market. I mean, they have dominant market share when it comes to protocols. Now, I'm not saying BACnet IP is the best. That's not my personal stance, but it is the most prolific and it is the most widespread protocol. Folks are like, hey, what protocol should I use? You don't really have much of a choice outside of BACnet IP. I mean, sure, there's other protocols out there, but they just don't have the line card. They don't have that product depth that BACnet has. With that being said, we're going to be, as I mentioned, focused on BACnet IP is going to be our protocol. We're not really going to talk much about it in this episode, as we're going to be focused mainly on the hardware aspects of controls and essentially these three controls architectures. So what's going on here is that we've got these three architectures, and these three architectures are known as the star pattern, the bus or daisy chain pattern, and then the ring pattern. So when I say pattern, it's an IT term. So you'll often hear if you've been through our programming course, you'll hear of design patterns. It's how we teach programming. If you have been through our IT course, you'll hear of also design patterns, but from a different perspective, from a network and a virtualization perspective, things like that. Because in the world of IT, everything's about patterns. It's all about process. That's a leg up that IT has on our industry as a whole, is we seem to do everything. If you were to go to 20 different controls contractors, they would have 20 different processes for installing. And, that's something we're working on here through our courses, is creating standardized processes. But when we say patterns, what we mean is a repeatable kind of instruction set. So a pattern, a star pattern, starts with a network switch, which if you're listening to this episode after the previous 4 episodes, then this should make sense to you. If not, I recommend you go to the previous 4 episodes. I think they're episodes 119 through 122. If I remember correctly, it may be 118 through 122. And those go through all of the network information you're going to need to understand to really grasp this episode. But you have this switch, right? And the switch has its physical ports. And you have access links from the switch's physical port to the IP field controller. It's a one-to-one relationship. You've got one switch going to, or one switch port going to one controller. Now, a switch may have many ports. Some switches have up to 48 ports. And what happens is with this star pattern is it's basically a star, or essentially a hub and spoke is what some folks will say, but technically it's a star. It's not a hub and spoke. So a star pattern is the switches in the middle, and then these lines emanate out from the ports on the switch to the actual field controller. So theoretically, a switch could have 48 ports in most cases coming out of it, and those 48 ports would go directly to IP field controllers. Now, the benefits of this are that you have a single run. So if there's a point of failure, yes, granted, the switch could fail, but in all of these topologies, the switch could fail. And so that's just an accepted point of failure. That's just like saying the supervisory device could fail. Well, yes, it could. So the switch, supervisory device, they could both fail. But what we're talking about with point of failures, we're talking about the actual link. You have a single link from the switch to the field controller, thus it's a single point of failure. Also, since you have a single link from the field controller to the switch and from the switch to the field controller, you can utilize power over Ethernet, which essentially is where a couple of the conductors, so with an Ethernet wire, you have 8 conductors. You have basically 4 sets of 2 twisted pairs. And what's going on is you can actually send power across some of those wires. And with some of the power over Ethernet standards, you can get, I think it's upwards of 60 at the time of this recording. I know they've talked about 100 watt power over Ethernet. I don't know if that is an accepted standard yet. Cisco's kind of led the way on high VA, or high wattage rather, not high VA, high wattage power over Ethernet. If I remember correctly, it's like a 12 volt DC to like 50 volt DC across the wire. I'm not 100% certain on that, but that's something that can be easily Googled. And then you have wattage coming across that wire. So essentially, in theory, you could power a decent amount of load on a field controller. Typically a VAV box you could power, and or a unitary controller that's relying on just dry contact relays, or 24 volt pole no draw relays, where you're going and you're sending 24 volts out to a pole, and you're energizing. Did I say pole? I meant relay. Yeah, sorry, not pole. You're sending 24 volts out to the coil on the relay, which is then causing the poles to change state and allowing the electricity to go through the circuit. So there's really no amp draw on energizing that coil. So with that being said, the star pattern, really good for single runs. Really nice that it has power over Ethernet with most manufacturers that support it. And also it's easier to troubleshoot because you have a single run. Now the cons are cost. I mean, think about it. Not only do you have a run for each individual controller, but you also have all of these ports that you have to go and pay for. And 48 port PoE switches, I mean, they can be upwards. Some of the more expensive ones are anywhere from $6,000 to $10,000 each. Contrast that is the cost of a single supervisory device. So, and that's only for 48 ports. Now imagine if you had to do 96 devices. Then you start to see that the costs add up. But at the same time, you've got the fact that you can power the controller and it's a single run. So usually star pattern is utilized for major controllers. It's utilized for air handler controllers and maybe central plant controllers, but it's not typically utilized for terminal unit controllers, as those are high density. You're going to have, usually it's, for a chiller, I mean, you may have 3 or 4 chillers in a large building. And in a large building, you may have 20, 30 air handlers, but you may have 200, 300 terminal units. So you can see the controller density of that kind of is a factor of 10, right? 2 to 3 chillers, 20 to 30 air handlers, 200 to 300 terminal units. Those are just rules of thumb, but they tend to play out that kind of factor of 10 increase to your count of your actual controllers. Not always, because it depends on the space dynamics of the building. Is it a building with a lot of spaces that want individual control versus a building with a lot of open cube farms, things like that. But with all that being said, star pattern tends to be used for that higher level equipment. Moving on to the bus daisy chain pattern, what that is, and it should be fairly familiar to any of y'all who have done controls work, whether it's sales, engineering, or as a tech for any amount of time, the bus daisy chain is very similar to the RS-485 pattern, which is what BACnet MSTP relies on, right? It's that serial, 3 or 4 wire connection, depending on how you've got your implementation of RS-485 set up. But in our case, we're using Ethernet, and this is daisy chain. So each controller is going to have 2 ports, and it's going to have an incoming and an outgoing. So you would have a single port on the switch, and then that would be your daisy chain run from controller to controller to controller. Now, the nice part of this is that it is like RS-485. So from an electrical perspective, all you're going to have to teach your subs is, hey, you need to learn how to crimp down some RJ45 heads, which essentially are those 8 conductor heads that go on Ethernet wire, and they're going to have to learn the color coding scheme of Ethernet wire. But other than that, that's what they need to learn, and then it's just a daisy chain pattern from controller to controller to controller. It's actually easier to install than MSTP because you don't have to terminate anything, and you don't have to do controller addressing. Also, it's a single port, so it's less infrastructure, substantially less infrastructure. I've heard anywhere from 128 to 200 plus controllers on a single daisy chain run. I don't know if I would necessarily put that many. It seems like you're setting yourself up for some issues, which I'll talk through in a second. but it's reasonable to say 32 to 64 on a run. That gives you some really good segmentation, and it also takes advantage of kind of those cost multipliers. By using a single port for 32 or 64 devices, you're now having a lot less ports and a lot less switchgear being IT switchgear, not electrical switchgear that you have to purchase. So those are kind of the pros. Now the cons are, now you have moved into a power dependency. At least at the time of this recording, the majority of the manufacturers out there have a power dependency on their network interface cards. What that means is on that actual controller, you have those network interface cards that the Ethernet ports are attached to. Now, in order for that controller to process the message, to process that Ethernet frame and that IP packet, and then forward it out the next port, you need to have power to those network interface cards. With BACnet MSTP, you could get away with a lot, because if you didn't have power at that controller, the wire itself was powered and it would just continue along. However, with a lot of these IP controllers using the daisy chain pattern or the ring pattern, as we'll discuss, if you lose power, you actually lose the ability to process the message and relay it forward. So that is a huge single point of failure. Now, that is one reason why it's not ideal to use the ring pattern for complex systems. You can use it for terminal units because you'll see pretty quickly where the break in the line is, because all the controllers downstream from that break are not going to be communicating. However, this also brings about things like, how are we going to do our power loops? It used to be that we would take 100 VA transformers, link them all up, and then run a common run to 20, 30 field controllers, and that would be our power loop. Nowadays, with this kind of issue of having power dependency on network communication, you need to be cognizant of how you build your power loops. You may actually end up using smaller power loops, so maybe a single 100 VA transformer for every 3 to 4 controllers versus using 6 of them and going to 20 plus field controllers. That way, if one of those 100 VA transformers dies, you only lose a little bit of the trunk. Well, actually, you would lose everything downstream from wherever the power break is, but you would isolate the power failures. Now, as I mentioned, not only is there power, there's also a single point of failure, because it is directly connected to the switch, and if that port, anything happens, that will cause a failure. And it's also more difficult to troubleshoot. So with a star pattern, it's very simple to troubleshoot from an IT perspective. You make sure the port's up, you make sure you've got port communication, you can ping directly out of that port. However, when you're dealing with a daisy chain, while logically it looks like a pattern, physically it is a bus pattern. What I mean by that is, logically, if you were to look at this in software, it would logically look like all of these devices are connected to the switch singularly. But physically, we know that's not true. We know that they are going along this message route. So there's all sorts of data gremlins that can take place in between that switch and the final field controller on that run. And we need to be cognizant and accept that potential issues with troubleshooting will occur, potential data collisions, and just all sorts of IP fun. Also, there's the issue of size. And this stretches actually across star and bus and ring design patterns. And that is that up to recently, we've always been, hey, give us a /24 subnet, give us 254 hosts, we'll put our supervisory devices on there. Maybe we'll even take a /26 network and get 62 hosts instead of a /24 where we get 254 hosts. Now here's the thing, I hear a lot of folks who are like, oh man, I could put all of my field controllers on this IP subnet. It would be awesome. And I'm like, remember, BACnet is primarily a broadcast protocol, at least in its local subnet. So as soon as you go and you decide you want to put 1,000 devices on a subnet instead of 200, which I don't even recommend 200 on a single subnet. I recommend right around 64. Think of these as field trunks and keep those subnets smaller than 100 devices. Because remember, someone is going to have to get in Wireshark and troubleshoot this thing if it doesn't work. And the last thing you want them having to do is sort through 5,000 field controllers communicating at the same time. Not only will that slow down response, but it'll also just cause all sorts of issues from a network troubleshooting perspective. So really want to target 100 field controllers or less for your sizing of your individual subnets. Now moving on to the final design pattern, the ring pattern. This is like RS-485, but with redundancy. Essentially, we now use 2 ports coming out of the switch. One port goes one way, the other port goes the other way, and they complete a ring. And what happens is, in theory, if one of the ports goes down, the other port will start communication. And if one side of the field controllers goes down and is not relaying information, the other side can start relaying. So the impact of failure is lessened, not eliminated like what we have with the star pattern, but lessened from the bus pattern. Also, there is the premise that with some manufacturers using the ring pattern, you can go about and communicate faster because you can communicate out both ports. But let's be honest, all this hoo-ha about your BAS is going to flood you with data and you're going to be destroyed because there's so much data and you don't know, that is a bunch of baloney. BAS data is tiny. If you don't believe me, go search. Steve Kargs has a ton of Wireshark captures. You can look at the size of backnet traffic. It's not changing. Even if you were to go and put SQL in every field controller like some manufacturers are doing and do massive uploads of SQL data and trend data and all sorts of other stuff, your data velocity, meaning the speed and amount of data that would be heading upstream, would be tiny. We're not talking 4K video here, folks. We're talking bits and maybe 16-bit arrays. So we're talking very small amounts of data, and that is for at least the foreseeable future until someone decides to put together a field controller that does video surveillance and BAS on the same field controller. We are not looking at, and honestly, I don't know why you would do that, because right now, cameras are IP native, so they just go directly to the switch through their access links. So I don't even see that happening. With that being said, so as I mentioned, not the star. I was going to say the star. The ring pattern. Man, I'm excited. I'm really enjoying this episode. I've been doing technical episodes for so long. I'm enjoying listener questions. So just a segue, if you've got a listener question, then shoot it to support@buildingautomationmonthly.com. That's support@buildingautomationmonthly.com. Would love to get your question queued into the podcast. That being said, let's continue. So you've got this kind of dual port infrastructure. It's less infrastructure than the star pattern, slightly more than the bus daisy chain pattern. Now the cons are there's a slightly higher cost. I mean, there's going to be a little bit more switch utilization, but not really that much. It is power dependent, just like the bus pattern. So you've got to accept that daisy chain bus pattern is going to have that power dependency. It now has a dual point of failure instead of a single point of failure, but that's still 2 points of failure versus with the star pattern, it's, that controller, and that's the only thing that's going to fail. Unless the switch goes down, then we're all screwed. And it is more difficult to troubleshoot. It actually is even more difficult to troubleshoot than the daisy chain pattern. With all that being said, that is the pros and cons of those 3 design patterns. But now we've also got to consider that IP controls are not just these 3 physical design patterns, they're also wireless. So what I'm thinking we'll discuss in the next episode, we'll be talking through the pros and cons of the different wireless approaches to field controllers. So we've talked about wired, and I'm believing in the next episode, we will go through things like Zigbee and Ocean and Wi-Fi. And we'll talk about point-to-point. Had a recent post in our Facebook group about a secure implementation of point-to-point for a 400-meter broadcast from a remote site to a local site. And how could that be accomplished? What topology and what architectures could be used? So we'll unpack that in our next episode. Now, if after hearing all of this, you're like, man, I do not know how to make sense of any of this IT stuff Phil just talked about. It's all Greek to me. I'm trying to figure it out. I know I need to know it because I need to deal with my customer's IT or my IT group. It's going to hold up a project I've got coming up, and I need to get up to speed with IT as fast as possible. Well, if that is the case, then you're in luck. We have a free 4-part series on IT. So it's a free 4-part video course on IT, and that will be available to you at buildingautomationmonthly.com/123. Once again, that is buildingautomationmonthly.com/123. That is where you will find the show notes from this episode. You will also find a link to that free mini course. Really encourage you to enroll in that. It's a great primer on IT. And if after going through that, you decide you want to do our full-blown IT course, definitely encourage you to do that as well. And until next time, if you have any comments, leave them in the comment section. If you would like to ask a question and have it answered, then go to support@buildingautomationmonthly.com or leave it in the comments section. And we will talk to you again next week in episode 124, where we will be talking through the different approaches to utilizing wireless in your building automation system. Thanks a ton for being here. Great to talk to you all again, and can't wait to talk to you all next week. Take care.